Okay, I think it's recording now, I hope. All right. Now, today is on the second topic, which is on robot application. Okay, so let's start. Okay, now, so just to mention further, a robot structure is actually a combination of the joint motion and the three major axes. Later, I'll explain what are the three major axes. And why do we use robot? Is actually, yesterday I mentioned already, productivity increase, they can replace human can never match a robot. And therefore, it's being used in a very rapidly expanding area, which is military, manufacturing, even home use, and also commercial restaurant. They're actually starting to use robotics already. So actually, when we select a robot, we have to consider quite a lot of characteristics. Okay. So today we are going to talk about the characteristic and the classification. All right, so okay, let's start. So how do we actually classify a robot? Actually, we have four major sectors that we need to consider. First is the mechanical configuration, the freedom of motion, the drive system, and control system. I'll explain one by one on further down the topic. Okay, so when we talk about mechanical configuration, we are actually talking about the whole structure of the robot. What it consists of, what the three parts consist of. Okay, so you take a look, actually, if you split the whole thing, actually there's three major parts, right? And later I'll mention what the three parts are. So the next one is actually, when we want to refer robot, we can also consider what is the freedom of motion. When we are talking about freedom of motion, we are talking about how does the robot move according to program. There's actually three major types that you have to learn and also have to remember for, as per usual, September. Okay. And the drive system next is actually meant what type of power you're going to use for the robot. Okay, same thing. There's three major types. Actually, if you think about it, you can recall year one you actually learned about this three drive system. Just that I don't know how many people remember. All right. Okay. Now, and finally, the control system. What is the technique and system used to control? All right. Basically, actually got two major class only. Which is one is the closed loop control. You'll learn further down the road. Another one is open loop control. All right, which is that mean non-controlled level. Right. Okay. So now, when we classify and categorize the robot, actually there's 6 main classes. And JIRA in Japan, all right, Japan Association, Robotic Association, and they actually classified for input, teaching, and running of a robot, and these 6 of them. Okay, first, manual, manipulator, second, fixed sequence, third, variable sequence, playback, NC robot, and intelligent robot. We go through one by one. First, when we talk about manual, manipulator, this one means something like you use a remote control to play a remote control car, or you use a remote control to play a drone. This is what we call by manual manipulator. You're using a remote to play, or should I say, to run the robot. That means you press the button and direction to move the robot, something that you play a game. This is called manual manipulator. All right, human total control. Okay. Now, fixed sequence is actually you record first. That means you record the individual position, for example, position A, position B, position C. And you program in such a way that you go to position A first, then go to position B, go to position C. Then once you record finish, you run the program, the robot will go according to this position based on the speed also. All right. And this is once you recorded, you cannot change anymore. It's something like, okay, washing machine. If you ask your parents, they'll tell you, I will set the wash to 25 minutes. I'll set the rinse to 25 minutes. I will set the speed to 10 minutes. I run. Then the washing machine will run according to this sequence. And during the running, you cannot change the sequence anymore. If you ask your parents, they tell you can't change it when you run unless you stop the whole thing. Okay, this is what we mean by fixed sequence. All right. For robot, it's the same thing except that the robot can move around. Okay. So where's my mouse? Next, variable sequence. This one is the same as just now the second one, the fixed sequence, with the exception of the program can interchange. Halfway down the road, you can pause, change it, run, carry on. Okay, this is the only difference. Other than that, everything is the same. All right. Playback. Okay, this is a bit different. Playback robot is something later you'll see a video on what we call by playback robot. Playback robot is very different. Playback robot is actually you holding the robot arm and you move it with your hand. And when you move it, you record exactly how your hand moves the robot. All right. And it can play back exactly how your hand moves. It's very useful for drawing, painting, and welding. Those that you need your hand control one, continuous motion one. Okay. Typically, they will use the playback robot class. All right. Okay. NC is different. NC is actually they stand for numerically controlled robot. This one is actually they are talking about CNC machine. Right? CNC machine is also classified as a robot. If you're not sure what is the CNC machine I mentioned yesterday, you can go to the PEG lab, okay, which is just beside the aerospace. The opposite of the corridor, you can see a lot of big machine there. Those are CNC machine. All right, they are also classified as robotics level. All right, because there is actually quite a lot of motion inside. Okay? And finally, intelligence robot. Okay, this is the most advanced of all. Currently, it's still in development, not 100% out yet. This one means the robot can actually perceive the environment and work according to the change in the environment. All right, and it can also feel. That means they can know exactly how much force to grab the object. For example, you want to grab an egg versus you want to grab a rock. Actually, the force is different, and the robot actually they can actually sense the difference and make sure they don't crack the egg. All right, or the robot or the rock, they can actually feel how much is it needed to grip and pull it up. Okay, this is what you mean by intelligent robot. Now you can see three of the robots actually are put in red because actually these 6 of them, only 3 of them is classified as robotic in US. Okay, for Japan level, actually they classify all the 6 as robots, but for US they don't. They are more particular. Okay, they only classify these 3 as robots. The rest they don't classify as robot. They only classify as machine level. All right, they don't classify as robots. They only classify the black color one as machine. Only the red color level they consider as robot. Okay, they don't consider any other things as robots. Okay, that's the whole problem. All right. Now, okay, so why do we need the robots? Okay, now mainly, well, this one yesterday I got talk about it. Okay, first thing we are going to go through again one by one. All right. First, reduce labor cost. You take a look at the picture, you know what exactly I mean already. All right. Okay, industrial robot, they don't want pay increase. Like us, every time, every year, hey, boss, please add my salary. Boss, please add my salary. A robot will never do that. Okay, once you buy the price, it's that price. End of story. All right. The only difference is the electrical bill. Okay. They also don't need holiday. They also don't need the sick pay or any other burden. Not like this guy here. Like a lot of you guys so I'm sick. I want to take MC. I cannot come today. That one will increase the labor cost of a company if you do that. And that is why a lot of companies actually give you only a fixed amount of leave. Typically for MC is about 14 days in the private sector. All right. Sometimes good one will give you 30 days, but normally don't. All right. And a lot of companies actually got this policy is that in 1 year you take more than 3 days of MC, your performance bonus will drop. All right. A lot of company does that for the HR. So you better take note. Okay. All right. So the next one, availability for work. Okay, so robot work 98% of the time. Not like you guys, you see, fall into the bed, sleeping. A lot of you actually does that. Even in the class, you also do that. All right, so you know exactly what I mean. So, increase product quality. Okay, this one is the robot will never be tired. All right, and they are producing at a consistent rate. So, you will take a look at these 2 humans there. They are working at this time. Of course, this one is forward already. But you can see that if they work here for 24, should I say, one shift is 8 hours, they work continuously for 4 hours. Based on this rate of working, sooner or later, they will make mistakes. Cannot run away because the human will get tired. And now you keep on doing the same thing repeatedly and repeatedly and repeatedly, the quality sure will drop, especially at the end part. All right, this will have happen. This will happen. All right, so this is actually not applicable to robots. Okay. Okay, increase productivity. This one, what I mean is quite straightforward. A robot is faster, in short. All right. Okay. A robot way faster. Okay. You can make 1, they can make 10. You can make 10, they can make 100. So how well you good, how good you are, you'll never match a robot. And not to mention, they will never make mistake. You will make mistake. Okay. Okay. Improve quality control. Okay. Improve production control. This one means that the quality is very consistent. Human, we still have to go through QC. But then for robotic process, typically the QC level is very, very low. They check very little things only. And 95% of the thing, no problem. Some for human level is 95 to 90%. But for robots, it's 99.9. So you can guess how good a robot is. No way to match for human. Okay, so this one I mentioned before, hazardous area. Okay, human cannot match. You work in a hazardous area, for example, the gas chamber, less than 2 days, you get M3 already. High chance you want to die. Okay, but then for robot, no such thing. Okay. Flexibility, this one is very easy. This one I also mentioned before. Any new project, a robot can just reprogram and change the gripper, they can do the job. Human cannot. You need to retrain. And typically for human retrain is 3 days to 1 week on average, all right, for the process level. And finally, integration with automation. Okay, they can easily integrate any machine down the road. No problem. All right. So we finished the why we need. Now we are talking about the industrial application first. So type of the application is shown here. All right, you can see there's quite a lot. Machine handling, machine loading, spraying, welding, machining, assembly, inspection, and you got quite a lot of examples. Okay, don't worry about all this because later down the road, there will be a chapter on this introduction of what is all about this. Okay, this one not really that important. It's more for you to see only. Okay, because I'll explain further down the road. First thing, material handling. When we are talking about material handling is they are actually picking up or transferring of parts or object. If you take a look at the animation, this is actually showing what is material handling. In short, they take the material, throw into another area only, just like that. Okay, this is what we call by material handling. Okay. Okay, so, and this is actually called palletizing. All right, same thing. Palletizing means you actually take the parts and arrange it in a pattern format. This is part of your phase test. Okay, and your phase test later, actually, you have to do the programming for this particular thing. Okay, don't have to worry, because it's, after you go back to school, you learn about this. It's not that difficult. It's quite easy. Okay, I don't have any student that got a problem with this yet. All right, so this is palletizing. Hold on, somebody cannot join the meeting. Let me settle his problem. Okay, let's get back to the class. All right, one of your friends cannot join. Okay, he go to the wrong location. When you want to join the meeting, please remember, go to your topic level, the channel to join. Okay, I will not be holding the meeting inside the general area. You'll be in your class level only, the lesson level. All right. Okay, so let's carry on. Okay, now next is machine loading. Machine loading is a bit different from material loading. Material loading is more for parts and stuff like that. But for machine loading, we are actually talking about loading the parts into the machine or out of the machine. Of course, out is called unloading. Go in is loading. So you can see for this robot, it is actually showing you that they load the part into the machine for further process. This is called machine loading. But for just now, this one is different than palletizing. And this one is actually material handling because they are not taking into another machine or taking out from machine. They are just transferring from one location to another location. All right. So there's a bit different. Get it clear? Okay. It's different. Material handling and material handling. Okay. Machine loading is machine loading. Different thing altogether. Okay. All right. If you see a robot, take the thing, go put inside a machine, convert machine loading already or unloading. All right. But if they just throw to another side, for example, a conveyor or stuff like that, it will be called as material loading or unloading. Okay. Now, this is another machine loading robot. Okay, they're actually loading into the machine level for working. All right. And typically the robot for machine loading is actually combined with the machine together. They will actually lock into the machine together. All right. Most of the time you'll see this. Of course, there are exceptions because some machine, they don't provide the robot. You have to buy from external vendor. For example, ABB or Koya. Then you have to integrate them into the machine. All right. Two different brands altogether. Okay. But no problem. All right. Okay, now. So, yes.
What's that machine? Like what is it? Is it assembly?
This one.
Yeah.
Oh, this is a lathe. Lathe is actually a cutting machine, a rotating tube cutting machine. All right, this is lathe folder. Because see before not in your NITEC or higher NITEC direct.
It's like for those precision, like
yes, precision machine cutting, correct.
Okay.
Typically, for machine loading, the machine they load it is typically only got two major types. One is assembly, one is machining. Machining is either you do a lathe or milling machine. Very commonly is for this few types. All right, this is a lathe machine, CNC lathe. All right. Okay, any question? Any more question? Okay, no question, we carry on. And typically for machine loading, their payload is higher. Payload, I think you'll remember yesterday what I said. Payload is weight, total weight of the gripper plus the whatever part is carrying. All right. Okay, so this is, that's why I say this is, they are actually interlinked most of the time. The machine and the robot. All right, for machine loading, they have to. Okay, otherwise the machine start running, the robot keep trying to put the thing when the thing is running. Okay, good luck to you. The robot arm confirm gone. Then $200,000-$300,000, your boss will call you to pay for it. Okay, so that's why normally when they, especially when they buy a machine and buy a separate robot, that means another brand to integrate. Typically, they will call the two vendors down into the factory to work together. They have to know each other how the machine works. Otherwise, they confirm accident, guaranteed one. And one robot very expensive. Not to mention about this machine. CNC full 7-axis machine will cost typically about $1.5 million. I don't really think you can afford to pay $1.5 million if it's spoiled. Okay, so it's quite careful. So next is welding. All right, welding is also used for robotics. This is one particular robot that they can see. This is what we call by spot welding. Spot welding means go contact and weld. It don't move one. It just touch the area. All right. And welding, why we nowadays use a robot? Because seriously, they're getting lesser and lesser welders, especially for Singaporean. Singaporean, most of the welders is actually from Bangladesh or most of them from Bangladesh, all right, or Myanmaris. A lot that come over to be a welder. They are very experienced welder. But the main thing is that it's very intensive on the eye. I think you know, when you do a welding, you need to wear a shield for the eyes. And the smell is very, very strong for the metal smell. So not a lot of people want to do this. But actually, their pay is very high. Professional welders, their pay can go to 7K and above. All right, not a lot of people know. But the only disadvantage is you typically don't work in aircon room. All right, that's the main thing. All right, and then you have to stand. There's no such thing as sitting down to weld. It's too dangerous. They'll always stand at weld. So a lot of time, a lot of companies actually replaced by robot. But if they can, they'll always get a human. Because human is more experienced in welding. The whole problem is not a lot of people want to work, although the pay is high. Okay? All right. So welding, you can see there's advantages because human can only weld for how many hours? Typically, a welder, their one-shot welding is less than 1 hour. Then they have to rest because the eyes cannot take it. The body cannot take it. The welding gun is not light. It's quite heavy. All right. And a robot can actually don't care. Just weld and weld and weld and weld and weld and weld non-stop. So they actually like to use a robot more nowadays rather than human. Okay. So that's why they say no delay, no interruption, no fatigue. Okay. Okay, now, so okay, for welding, actually they are programmed by walkthrough. Just now I mentioned about walkthrough thing, that word. Okay, later on you'll see what I call walkthrough. Because welding is a very specialized job in the sense that the human must be the one knowing exactly where to weld the object. So they will actually, a human actually will control the robot to do the operation once first before they allow the robot to do it, to make sure nothing is wrong. Welding still highly depending on the human skill, number one. All right, that's why in order to train the robot, the human will get involved. Okay. And of course, our sensor must be needed to use. Okay, we'll mention about sensor later on also. All right, so you can see a welding gun, just a robot alone. You just see, okay, if I don't know how many people can see clearly, this whole thing is the end effector. And I mentioned before, the payload is the end effector plus the load. But for welding gun, they don't have load. They only got the end effector. And this end effector alone weighs about 15 kilo. So you can guess how heavy this is. You try to carry this to weld, and you see how fast you get tired. Okay, less than 1 minute, I think you give up already. All right, this is a whole problem. All right, because in order to weld, there's pipe, oxygen pipe and stuff like that. Okay. So for welding, there's two types. One is called spot welding, one is called arc welding. What are the differences? First, this is called spot welding. If you take a look at this particular picture inside, Okay, I think it's moving on your screen also. You can see this robot actually go to a spot, stop, and the spark, then they go out and go to another spot. Right? I think you can see very clearly here. This is what we call by spot welding. It's contact. Something like you contact glue. You drop one drop of glue and push the two things together. So it's something like that. But the only difference is this is actually force the metal together, short circuit, and melt the metal together at one point only. And spot welding is very commonly used in car manufacturing. Your car body and the motorbike body, actually, most of the parts is using spot welding one, especially for sheet metal, all right, for large object. So you can see here for this picture, I think you could realize the whole place, there is no human inside. And how many robots is working together? Last time, this job is done by human. Nowadays, this job is purely by robot. This job is gone forever already, all right, for human. And as time goes by, more and more job is going to be lost to robots. In China, a lot of those restaurants, they are using serving robots. They are not using waiter or waitress anymore. Even you see NTUC, a lot is self-serving. If you go to US, you go to Amazon supermarket, they don't even have cashier now. You just take a thing and go out, walk out. The system will automatically capture what you buy and charge your credit card. If you didn't have a registered credit card, they will immediately sound an alarm, you can't even go out. This is how advanced the system is now today. All right, and that is why a lot of jobs is missing. If you thought that you can get away with just no education and work in the future, I'm sorry to say there will be no job for you if you keep on thinking in this manner, because a lot of jobs is going to be automated. Yeah, you're going to replace by either robot or AI system. You cannot run away with it. This is the future. The only way that you can work is you go for higher level education. You become a person that repair the system, or you assemble the system, or you commission the system. This is the only way you can get a high level job. Other than that, there's no way in the future you will have a basic job. In fact, delivery, yes, you can say that you do delivery now, grab food and stuff like that. But this job, I can tell you, in less than 5 to 10 years, is going to be gone also. Guaranteed gone. Okay, you'll be fully automated transfer a delivery system. It's already start to roll out in overseas. Singapore, I give you about 10 years, roughly there, fully automated also. Maybe, I'm not sure, but it's a maybe. And if this thing really came true, all delivery job also gone, literally. So future is hard to tell. So make sure that you are prepared for it. All right. And the best way to prepare for it is learn more, get yourself educated, and make sure you get a better job. So this is spot welding, I just mentioned. And okay, spot welding, we have to consider these few things. All right. Okay, it's not that important, just know more information. If it's important for exam, I'll mention. All right. So the path, how it's moving, you can see the robot movement, how is it? The position of the gun. You can realize that the gun position is very specific. The access of the robot, what do I mean? This means that whether the robot can go to the place that you weld. If you realize this gun is very, very big, it's like a gripper like that, but actually it's a welding gun. It's very big. So the robot will be in a position that it can reach all the places that it's doing. That is why you can see there's 4 robots here doing the job. Why? One robot cannot do every part. Okay, this robot cannot reach this side. This robot cannot reach the other side. So they need actually 4 robots to do the job. Okay. Now, of course, if you are human, one person you can move around. All right. A robot you can't. Okay. And the coordination of the moving part and the welding station are multiple. This one will do a little bit, go to the next one, do a little bit, go to the next one, go do a little bit. All right. But it's very, very fast. Okay, it's very, very fast. Anytime can beat a human. Okay, now this is called arc welding. Arc welding is that the robot, when it weld, you move around the thing. And typically, they like to use for round object, round pipe. A round pipe, typically, they do use arc welding. They cannot use spot welding one because they have to weld the 2 parts together. So you can see actually moving together. There's quite a lot of different techniques. Okay, but this is one of them. All right. And they actually show you how versatile the robot is. 2 gripper plus another 2 welder can work together without crashes and very, very smooth. Okay. All right, this is also arc welding. Okay. Arc welding, sometimes it can use gas or use electric. Typically, electric is more for spot welding, but there's also certain cases that use electric. And you can see this gun is actually moving or welding. This is a bit of round object inside, that's why they need to move. And you can see the gun actually moving it and melting the thing. You can see this is the behind. It's actually, this light is actually a plasma, a gas. They use it to weld the 2 objects together. All right. Okay, this is also arc welding. You can see the robot is here. You can see a little bit of lightning bolt. All right, this is actually the one that I mentioned using electricity. Okay, and you can see that actually you can see this little bit of gray color thing. This is actually sand. Okay, they put the sand there to prevent any other area from melting. That's why you see the center here is like a liquid metal. While these two parts, you can see they actually vacuum the sand away, right, and put it up here again. Okay, it's to prevent the number one, the electricity from going to other location other than inside the target position. This is to lock the electricity down, the lightning bolt, to a straight line position. Second is to prevent the metal from melting any other place other than the place that they want. All right, these are two locations for it. Okay, two purpose for it. This is called arc welding also. All right, that's why you can see the line is very smooth. Okay, spot welding you'll never get this type of result. You'll see one dot, one dot, one dot, one dot, one dot. Very ugly one. Only arc welding can give you this type of pattern. Okay, and of course that they are more expensive. Right? Okay. So this one I'll just mention. I'm not going. This one is the same thing. I just now mentioned it's the same as spot welding. They also need a lot of support material. For example, your gas and stuff like that. Right? Yeah, a lot. Okay. So another one that we use for it is spray painting. If you take a look, this robot arm is actually spraying on the plastic panel. And spray painting, a lot of people thought that, hey, you spray, is it that you spray paint? No, in robotic world, actually they don't spray paint. If you take a look at this robot, there's a black color covering on it. This black color covering is actually to prevent the paint from sticking to the robot arm or go into the joint, the motor joint. If the joint part, all the paint go in, and you know paint will actually is sticky. Okay, although this is not those sticky paint, but when you accumulate, your hand will jam. All right, once you jam, you cannot use. So for spray painting robot, either they wrap it up with plastic or with or cloth. It can be different color. For car manufacturing, typically they like to use plastic, right? For this, they use a cloth. And for spray painting, typically for robotics application, although I hear say that they use a paint or stain, but the paint is not the one that you're thinking of. Actually, what they spray is powder, pure powder, right? And this particular part is actually, if you take a look, they're actually contacting on another surface. This surface is actually electrified. Typically, is negative or negative type. And the spray, there's a spray out, they actually ionize it to be positive. So, you know, positive and negative will attract to each other. So the paint will automatically stick to this surface straight away. Because of the plus and minus, the paint will actually stick to the surface. This is what we call by coating, right? This is called by powder coating. Okay, powder is actually the paint. But a lot of didn't realize that it's actually powder coating. It's not the paint, it's the powder. Right, this is how they do it for robotics. Okay. So you can see further down the road, you'll see actually I will also post up some factory videos that you can watch and see exactly how does the factory do for different products. And it's actually quite interesting that you take a look. All right. And also, I also already post up the video of the history of robots. So you can actually take a look and see how actually robot evolved over the years. Okay. It's inside the video folder. All right, the same place that you access your textbook. Just inside the video folder. Okay, now next. Okay, this is also spray painting. You can see this robot. You can see this is a bit different. The one they wrap up, you can see here on the top or near the arm, they actually wrap up with plastic. Okay, and the side they actually use a cloth. So car manufacturers like to use robot for spraying because it's way faster and the spray speed is very fast. You can take a look. The one that they spray is powder. Same thing. It is not paint. It's powder. Okay, and normally for the motion that you use will be 6 or 7 articulated robot system. They only use this type of spray paint. All right. Okay, so normally same thing. It seems like your welding, you need to teach by walkthrough. All right, walkthrough means you hold the robot arm and spray first by a human, and the system will record how you move the thing. Once you move finish, you click stop, you click run again, you go through exactly the same thing and how you do it. All right, and this is how they actually train a painting robot, spray painting robot, even handwriting robot to do the job. Normally they use this system. All right, a walkthrough type. Okay. So normally it was spray system. We have these 4 type. Okay, 4 type. All right. Air spray straightforward. Air spray is powder. Okay. Electrostatic spray is also powder type. Heated spray is actually they use the paint pellet. They melt the paint pellet and spray it up. All right. It's a bit different. This heated spray not a lot of people use because it's once you spray finish. Let's say your factory needs to stop. They need to de-assemble everything and clean out the thing. And it's very troublesome. Okay. The top 3 is actually more of a powder type. So the cleaning is very easy. This one is quite headache because paint actually melt inside. All right. Okay, so now for this, okay, I'm going to mention a bit only. All right, not really that important because for spray painting you need some special requirement. Number one, motion of part together with the robot. You have to know the part typically. Just now you see the robot that actually spray paint the paint. The car is actually moving. The robot is fixed position. The car is actually moving. So when the car is moving, the robot actually spraying. So these two motion must coordinate. If you don't coordinate, normally your spray go crazy. All right, some part got spray, sometimes never spray. Some part you spray too thick, and the problem was that. Sensing for presence of part. Of course, the part might be there, then you spray, right? If the part is not there, you don't spray. So you typically have sensor for it. You must have sensor to tell you the system that, hey, the part is here. Can you please spray? Can you please swell? And stuff like that. Controlling the timing or changing of color or spray. Some robot can do it. They can one shot spray 7 color. You can actually program different color. They can even mix the color when spraying. All right. So this is more advanced. And of course, precise alignment. All right. You don't align same thing. You spray wrongly. Okay. Now, deburring is another application. Deburring is okay. I don't know how many people have done it. When you are in the workshop, you cut a piece of metal using a saw. After you saw what happened to the edges, very, very sharp. There's small little spike and sharp, right? Deburring means remove the spike to make it not so sharp, will not cut your hand. All right. This is what you mean by deburring. And typically we use a file. But for robot, they will actually use a rotary sandpaper type of tool to actually remove all the sides. Right? Okay, and it's very, very high speed. Okay, now let's ask you something. For deburring, okay, for robot, all right, you can participate and try to, okay, I'm going to use the chat level reply. What is the speed that you think in RPM level that the deburring machine will spin at? Try, guess a bit. Okay, try. You want to unmute to say also can. You want to type into the answer also can. Wait, try it. Otherwise, cannot carry on. Any guesses? Or all sleeping already?
So is it like
12,000 to 20,000 RPM?
Okay, any more guesses? Any more guesses? Only one. Don't like that, guess a bit.
I don't know.
100.
100. Okay, any other?
300 RPM.
300 RPM. Okay. All right, but okay, the first answer is good. Wow, you really know your stuff. Yes, deburring tool actually you will spin at 10,000 to 20,000 RPM. Typically.
Wow.
Very, very high speed. All right, because the machine for machine is not like our human. Our human we use a file. Okay, very, very slow. But human sorry factory cannot work at that type of speed. Too slow already. Theirs is very, very high speed. And the tool at the top, at the bottom that they send is a diamond coated tool. All right, the diamond is not like your ring, the diamond. It's not worth that much of money. That is the industrial diamond actually. Okay. All right. Okay, now, so this is deburring is actually very hot and dirty. As per usual, humans don't like to do it. That's why actually they use a robot nowadays, and it's very, very fast. Later on, you see application, you see that it's very, very fast. Okay, now, and finally for assembly, okay, robot also used for assembly nowadays, especially the point little parts, they actually use it. Okay, now, it actually just means 2 parts add together. Okay, A plus B equal to C, that's all. Okay, and this A plus B equal to C, normally they are quite labor intensive, right? And they'll actually make some errors. For human, that's why they always use robot nowadays. All right. Okay. So this is not so important. All right. Now, features of assembly. If the robot want to assemble something, this is the thing that they have to know. Or should I say they should possess. First is the robotic assembly system is typically lighter than your standard robot. Very light, and it's typically machine level. All right. And they are very accurate, freaking fast. When I mean fast, I really mean very fast. 1 minute can actually assemble about 2,200 over parts easily. If you tell me your fan can move that fast, I say you good. There's no way. All right. the robot for assembly is on average 1 minute 2,200 parts. So you can guess how freaking fast it is. All right. And the motion is very, very complex. They can go to very complex level. All right. And they can sense multiple area parts. All right. Okay, now, so, okay, this one I'm not going to mention, there's no point. All right. So this is, because I will show you a video, it's easier for you to know. All right. So typically, an assembler is actually, sometimes they got use support robot. Means the robot, another robot hold the thing for you, or another one assemble the thing. For example, 3 parts combined into one. They will typically use more than one robot. All right. Okay. And typically, it's one robot workstation level. All right. That they actually use to assemble. Okay. Now, of course, if you can put into one whole line, you can actually help to each other to assemble the thing. Okay, this is quite straightforward. All right, you cannot say that one robot assemble everything. No way, impossible. For example, just to assemble a TV alone, you need about 6 robots in one line. One robot do a little bit, one robot do a little bit. Final robot finish everything, put the cover on. All right, so this is what I'm trying to tell you. Okay, okay, this is very common. Okay, for electronics level, inserting. Okay. All right, so any question up to now? Anybody got any question? Please ask.
No.
No, so good. Okay, now.
Permission to sleep, sir.
Mission to what?
Sleep. Sleepy.
Sleepy can, but you must finish the assignment first. Because as per usual, the assignment got deadline time on.
Hiya, jalat.
That's the whole problem. I have to mention all the assignment, okay, because you don't do when you finish the 1 month, you go and answer yourself, not I answer to me. Okay. All the assignment, whether you got do or not, got all will be tallied up one. All right. So please go and do it. Okay. Any questions so far? Any question?
No, sir, no.
Okay. So wait, give me a moment. So let me see. Okay, now if you take a look under your assignment, same thing. I think, sorry, under your class, give me a moment. So under your class, under general, okay, your assignment should be up already. Let me take a look. Okay, yesterday one you submit. Okay, due today at 1 p.m. So you all know what to do already. Okay, let me take a look what time start. Oh, I think already started. So I think you can start to do already. By 1 p.m. It will close. Late turn in is not allowed. So you all know what to do already. Yesterday got some people also didn't submit. Okay, I know exactly who didn't submit one. All right, so you cannot actually run away. Okay, I show you how I know. All right, see, this one is yesterday one. All right, I can actually see what is all your score, which is under grades. Means who score how many marks and who didn't submit. All right, you can see if some of you didn't submit. Okay, don't ever submit. Sorry get 0. All right. Okay, clear. So must do. Don't say don't do. Okay, clear so far. Any question? Okay. If you don't have, okay, I'll end the lesson for now, and you can start to do the assignment already. All right.
Okay, Asia.
Okay.
All right. See you on Monday.
Bye.
Bye,
Thank you.
Asia. Have a good
Finally,
have a good day,
lunch.
Asia.
Amigos. See you
Finally,
soon
go and
in
do
1
your
month
work.
time.
Yes, of course.
Yes, of course.
Woo-hoo.
Finish record already or not? Yes.
Hey, you know I'm recording your monkey face now.
Hello,
Later you see your monkey face there.
Hello guys.
You all relax, right? On the bed, listen to lecture. Hey, remember to
How
do
are
your
you?
work.
Ali handsome.
Yeah, okay. Go and do. I'm going to cut off already. Okay, bye.
Bye, Asia.
Bye, Cha.
Bye.
Bye, Ali.
Share answer. Pain. Hey, Raz, handsome lah. Share answer.
Because
Yeah. Hey, where's the?
Yeah, I cannot find the work. I cannot find the.
Yeah, it's not fine. Where's the
Kali.
Can you find it?
juga kau
t-shirt assignment 2? Where's that?
I cannot find.
Boy.
aku baru pergi
I
ambil
only
makan.
got the previous assignment.
Yeah.
Apa?
Someone text him.
Baru pergi ambil makan, kelas dah habis.
That sounds so fast.
Tak ada cycle lah.
Yeah.
Ada diamond eh?
Ada.
Ya, nanti aku
Ask the fella
Wait,
lah.
why is zero? Zero.
Do you all know where the thing is?
Still trying to find. Another.
I also don't have there. Do you have it?
Carl. Hello?
Have it?
They are sleeping Conky all sleeping.
What's up? What?
Don't have, don't need do.
That's why he said he asked us to do, then he didn't even send. What the heck, man?
Hi guys. Hello?
Email.
Hello.
What's the local bot there? Oh,
Yeah.
sorry. Bro, you guys can hear me?
Hey, what's up?
Oh, looks like it's